So let's look at an illustration of the meaning of a 95% confidence interval. So I'll actually do this by looking at a simulation. So here we have the left and right hand sides. Those are representing the lower limit and upper limit of the interval. And then that dot in the middle is the point estimate. And then this is the population parameter. In this case, it's the mean, but it could be a population proportion. So if we select 100 samples and generate 100 confidence intervals here, then we can see the red here. Those are the ones where the whole interval does not contain the population parameter. And we can see out of 100 intervals here, 1, 2, 3, 4. So in a 95% confidence interval simulation, 96% of the intervals contain the population mean. And if we keep adding intervals here, increase the total number of intervals, then eventually we will get closer and closer to 95% of those intervals containing the population parameter. So here's our sampling distribution here in the middle. Population parameter P plus 1.96 standard deviations, P minus 1.96 standard deviations. So any P hat that lies within 1.96 standard deviations gives a confidence interval that contains P. So this P hat is between these cutoffs. So then when we add and subtract 1.96 standard deviations, we see that that population parameter falls inside this interval. However, for this second sample, P2 hat, that interval does not contain P. And we can see that P2 hat is not within 1.96 standard deviations of the mean. So this is the changeover between the two inequalities here. This one with the population parameter in the middle, and this one with the sample statistic in the middle. So whether or not a confidence interval contains P depends only on P hat, that sample statistic. So a 95% confidence interval does not mean that there is a 95% probability that a particular interval contains the population parameter, P or mu. What it means, 95% confidence means that 95% is the proportion of samples that result in confidence intervals that include the population parameter. So it's the proportion of intervals, not the probability one interval contains it. Those are closely related ideas, but not quite the same.